Good morning. My name is Sangeeta BL, working as Assistant Professor at Vivekananda College of Engineering and Technology, Puttur. Today we are going to study or make an experiment on design and test of R2R DAC using an op-amp, that is operational amplifier. So as we all know, digital to analog converter is nothing but which will convert the digital data into an analog quantity. So here we are using, so this is the circuit diagram of an R2R DAC. So you can see the digital data are nothing but your D0, D1, D2 as well as D3. So these digital inputs will act as a binary value, which is nothing but the digital inputs given to this circuit. Whereas analog value will be obtained at this circuit, that is V0, which is the analog quantity. So this op-amp, this is nothing but just a summing circuit, whereas this part is nothing but your R2R ladder network. So since this R2R ladder network uses 1 kilo ohm as well as 2 kilo ohm, that is use of only two resistor values, so it is called as R as well as 2R DAC. So in this circuit you can see the circuit is designed in the tag board here. So you can see the resistors connected as well as the op-amp here. So the 12 volt supply is provided from the fixed DC power supply. So this is the multimeter through which we measure the output voltage. So initially what you have to do is, so you have to give the digital outputs from starting from 0, 0, 0 to until 15, that is 1, 1, 1, 1. So as we all know, this, if I take an input say 0, 0, 0, 1. So this is nothing but the applied voltage we get here is V reference by 2. Whereas at this node it is V reference by 4. Here it is V reference by 16. And at this node it is V reference by 16. Sorry, this is V reference by 8. This is V reference by 16. So if you are calculating the output voltage, there is a formula given, that is 8 into D3 plus 4 into D2 plus 2 into D1 plus 1 into D0 into the total voltage. So this total voltage is calculated with the help of the voltage divider rule, that is V reference into your 2R, that is 2 kilo ohm resistors, divided by 2 to the power 4. So as we all know, that is a 4-bit DAC. So R2R DAC is a 4-bit DAC. So 2 to the power n value will take 4 into 3R. So V reference, your R and R will get cancelled. You will remain with 2 power 4 into 3. Above it is 2. So you will simplify, it will get 24. So V reference value, which is nothing but we are taking it as 5 volt. So 5 by 24 will give you 0.20833. So for example, if I take now, I'll take the bit as 1001. Sorry, 0. So it will multiply with 8. So 4 as well as 2 as well as 1 will become 0 into the total voltage which you have calculated will be 0.20833. So when you simplify, you will get 1.6664. Actually, this is not the near value of this 1001. So you can see here for 1001, which is the MSB bit will be 1001. So it should be V reference by 2. So V reference by 2, you are taking a value, V reference is 5 and 2. So 5 by 2 will be 2.5 volt. So actual value we have to get is 2.5, but when we do it using this formula, we will get only 1.664. So now we have to check through the circuit. So you can see there are inputs given. So this is the MSB bit, whereas this is the LSB bit. So I'll start from 0, 0, 0. For 0, 0, 0, there is nothing displayed on the multimeter. So if I keep it as, so now I'll start giving the input as 0, 0, 0, 1. So for 0, 0, 0, 1, I'm getting the output voltage as 0.37. So actually 0, 0, 0, 1 is what in the circuit? So the LSB bit is 1, rest all bit is 0. So this 1, I have the voltage as V reference by 16. So if I take that V reference by 16, that is 5 by 16, I will get around 0.3125. So this is the actual calculated value, this is the practical value we are getting. Almost it is very near to the practical value. So now go for 0, 0, 0, 1. So I will give it as 0, 0, 0, 1. 1, 0. So this is 0.66. So that is what I should give. 0 here, 1 here, 0, 0. So I should get a value of V reference by 8. So that is V reference by 8 is 5 by 8. So which you will get around 0.66. So that is same 0.65. Now check for 3. So 3 I am getting a value of 1.03. Next it is 4. So 4 it is nothing but I have to give a value here 0, 0, 1, 0. So I should get a V reference by 4. So that is V reference by 4 is 5 by 4, which is nothing but 1.25. So we'll see through this, it is, so we are getting nearly very equal, that is 1.24. So now check for 5. So 5 we are getting 1.61. 6, it is 1.90. Then it's 7, it is 2.27. So next is the 8. So that is nothing but your half the value of your V reference, that is 5 by 2 will get 2.5. So we are getting 2.38. So that is nothing but you can see here it is, as I have told you, 1, 0, 0, 0. So this is nothing but your V reference by 2. So 5 by 2 you will get 2.5. So now go for the next value, that is 9. So 9 I am getting it as 2.75. Again 10, it is 3.04. 11, 3.41. 12, it is 3.63. 13, that is 4. 14, it is 4.29. Last one, that is 15, 4.66. So initially if you have to check whether your circuit is proper, you can check for these conditions 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, and last one is 1, 1, 1, 1, because we know this voltage will be V reference by 60. This will be V reference by 2. Sorry, V reference by 16, V reference by 8. This is V reference by 4, this is V reference by 2, and this is nothing but whole total voltage of your circuit. So everything, if it is 1, 1, 1, total 5 volt will be supplied to this circuit. So we should get around 5 volt at this input of the circuit. So after you measure this input, so next thing is, I'll give you an example how to solve through theoretical. So now consider this bit as 1, 0, 0, 0. That is D3, D2, D1 and D0. So now you know the circuit. So 2 kilo ohm, 2 kilo ohm are 5 as well as 1 kilo ohm. So this 2 kilo ohm and 2 kilo ohm, they are in parallel. So I will solve the parallel equation. So you know it is nothing but R1 into R2 divided by R1 plus R2. So that is 2 kilo ohm into 2 kilo ohm divided by 2 kilo plus 2 kilo. You will get 4 by 4, that is nothing but 1 kilo. So this 1 kilo ohm which you get, then it will be series with another 1 kilo ohm. So if you have to calculate the node voltage, so that is nothing but your voltage divider rule. So what is a voltage divider rule? It is nothing but the voltage into opposite resistance divided by your total resistance. So since I am considering for this circuit, so voltage is V reference, opposite resistance is 2 kilo ohm, total resistance is 2 kilo ohm plus 2 kilo ohm. So I will get V reference by 2 as the voltage. So again this 1 and 1 which I have calculated, it is in series. So series is nothing but R1 plus R2 that gets added. So I will get 2 kilo ohm. Again the rest of the circuit. So now what I have to do? Again you have to simplify the circuit. So this 2 kilo ohm and this 2 kilo ohm are in parallel. Again you will get 1 kilo ohm. V reference by 2, opposite resistance is 2 kilo ohm, divided by 2 kilo ohm plus 2 kilo ohm, that is the total resistance. You will get V reference by 4. So again V reference by 4. Parallel circuit, you will get 1 kilo ohm as the total resistance. Another 1 kilo ohm, they are in series. When you add it up, you will get 2 kilo ohm. So now again the circuit has to be simplified. 2 kilo ohm and 2 kilo ohm are in parallel. You will get 1 kilo ohm. This 1 kilo ohm, 2 kilo ohm. This V reference by 4 into opposite resistance is your 2 kilo ohm divided by total resistance, that is 2 kilo ohm plus 2 kilo ohm, you will get V reference by 8. So this 1 and 1 again in series, add it. Again you have to find the voltage, V reference by 8, 2 kilo ohm opposite resistance, total resistance, that is 4 kilo. So you will get V reference by 16. So this V reference by 16 is nothing but the desired output voltage which we have to get. So this circuit will be simplified as V reference by 16 with 1 kilo ohm. So this is the circuit. So V reference is what? 5 by 16. So you will get 0.3125. So this is the desired output which you have to get for an input 1000. So same way you have to take different types of digital bits like 0010 or 0011. So apply the voltage divider as well as the resistant equivalent, then get the output voltage so that you can verify your theoretical result with your practical result. So after you do this experiment, so it is obvious you have to plot a graph. So this x-axis is nothing but your digital data, whereas y-axis is nothing but your analog data. So always we know when you convert a digital to analog, it is always in the form of staircase waveform. So here you have to take the analog data 1, 2, 3, same way until 15, and you know the output voltage will vary from 0 to 5 volt. So x-axis, so take the readings according to the for your convenience. Take it as 0.2, 0.4. So you can draw the graph in a nice staircase manner. So if I take 1, you are getting around 0.3, so it will come around here 0.3125. Again next one is 0.6. Next one is 1.2. So how your staircase waveform will vary. So at the same time you have to take the particular analog voltage. So after you plot the graph, you get a staircase waveform through which you can say that your digital data has been converted into the analog data form. So by using an R2R ladder network. So applications of this is you can use in the audio amplifier as well as potentiometers, radios and so on. So by this way your digital data can be converted into an analog data. Thank you.